Go to Google Classroom, Jason.
You got a good ride.
No, they usually not about to live in
Ooh, Nikon, that's fancy.
Good morning.
Morning.
Hope y'all's extended weekend was fun.
It was amazing. Minus my phone getting fried and what I did because of the internet. Where your phone broke? No, somebody spilled a whole like 79 Polish pie. 79 Polish pie.
Alright, so today I want to try and keep what we talk about today short to give you guys some live time. On Thursday, we did 4-1, which was quadratics. And so, we did the concepts for 4-2. 4-2 is applications of quadratics. So today we're going to spend a few minutes. Hopefully we can get done before lunch on doing just some applications of the quadratic. Okay, so before we do that, if I gave you a line, can you give me a situation that could be modeled by that line?
What do you mean by situation?
Just can you give me a situation where a line would be appropriate to use?
Why?
Function of x equals
So whenever, if you ever seen something on a test that's like, here's the graph, it gives you a line, right? And it's like, here's the graph of this, right? Some situation. Okay, let's think. What if I said this was time in seconds, maybe? Something like that. And this was feet. Couldn't I say something like, at time equals 0, I'm like 1 foot away? Or I'm sorry, like at time equals 0, I'm 0 feet away. Maybe at t equals 1, I'm 1 foot away. At 2 seconds, I'm 2 feet away, something like that, right? A situation where a line might be appropriate, right? But there's going to be situations where a line isn't appropriate. So let's look at one of those.
They can dive from the height of a 30-story office building, reaching speeds up to 60 miles an hour. And on the way down, they turn into torpedoes. Before they hit the water, Cape Gannets fold their wings straight back, transforming into aerodynamic missiles. And they do it perfectly with every single dive. A millisecond too late, it would be like plunging into a brick wall. With a quick underwater wing flap, they can dive to depths of over 40 feet. They can even swallow their seafood meal on the way back up, if they want to avoid a fish-fueled fight. This bird's body is built for impact. Air sacs and fat provide a cushion every time one hits the water. And their bright white plumage broadcasts to other seabirds to come join in the spoils. Faced with an airfield.
Okay, so we kind of get the idea of,
Oh, so like a real life app.
yeah, we're looking for some applications of that. This is a situation where maybe a line was appropriate, but if we look at the gannets when they're diving into the water to eat the sardines, is that an appropriate situation where a line would represent appropriately? No, right? So what did the kind of the curve, or what did the shape of how that gannet was diving, what did that look like? A parabola, right? It sort of, in a sense, looked like the gannet was starting somewhere here up in the sky, coming down, hitting the sardine, then going back up, right? So that's a situation where a line wouldn't be appropriate. The flight path of the gannet isn't just a straight line. It is starting up top, swooping down, grabbing the sardine, and coming back up. So if we can figure out if we were given a curve of this is maybe a function that represents the flight path of the gannet, we can solve a bunch of the information. Okay, solve for when does it eat the sardine, when does it cross into the water, things like that. And then don't I scroll down? I didn't have that one. Okay, so if we're given that the trajectory of the gannet's flight path is parabolic, is a parabola, so we can describe its flight using a quadratic function. We're going to describe the gannet's flight path using the quadratic function h of t equals t squared minus 8t plus 12. So you guys are going to work together and answer some of these questions. And so there's how many A, C, B, C, D? There's 6 questions. So we'll do the first 3 and then the second 3. So it gives you that function h of t equals t squared minus 8t plus 12, and you're going to plot that using some of the stuff that we learned on Thursday in 4.1, and then you're going to use the x-axis as the water. So the x-axis is basically breaking the plane of the ocean. Does everyone understand that? So if I was giving you, say hypothetically, right, this was the shape of the graph. The bird's in the sky here, this is all water underneath here. So whenever it breaks into, this is when the bird is breaking underneath the water. So you guys are going to work together to answer these first 3 questions, then once we do that, we'll scroll down to the last 3. So we can work together in partners. Who wasn't here Thursday? Raise your hand. Are you not here Thursday? Everyone else was here Thursday? Okay. Y'all can help me with the sheet. Y'all can put it on sheets. Hold on. Oh yeah, but that doesn't matter. All you're doing is plotting the ganette's height. The y-axis then would be the height.
8 times 0 is 0, so that would mean 12. So that's the only thing you
But
in this case, if you were to set the x to 0, it would be 12 automatically. That's the only thing that don't have a t by it, so everything is 0 is So if you put x to 0, which is t at this case, 0 squared is 0. 8 times 0 is 0. Just make it 12. So A should be 12.
just remember, it's how many seconds per. That's the ganette's initial height. So how many seconds before the ganette hits the water? The first thing you have to do is graph it. So graph how we graph on Thursday, quadratic. First thing you do is graph it. You can graph a vertex, right? Find a line intercept. So start there.
You do that.
First step would be to graph. First step would be to graph.
Because over to negative.
Well, yes, you can negative 6 seconds too. Okay, so zeros are going to be 6, 2. So 6 minus 2 is 4. So it should be 4 seconds, right? Oh no, not 4 seconds. How many seconds should it be? Because I just subtracted the intercepts. The positive 6. Oh, okay. 6 seconds, 2 seconds. But it's not like I did 6 minus 4, that equals 2. Oh wait, no, 6 minus 2, yeah. That's the difference in water. I get you. Into the water, I get you. So it'll be 2 when it comes to.
Thursday. What'd you do?
When it comes out, it'll be.
We have two forms of vertex. So for standard, in order to find the vertex, we have
Yeah, you explained to me how I got this.
is
Boy, hello, that did it wrong.
What does it mean? I know math.
12 is y, and 4 is
Divided by 3.
I think I'm understanding it so well.
1 is equal to sine of
I just feel like
Oh, man.
that graph. I mean, we kind of just backed it, like, yeah.
I did it, I got like a 90%. And I was like, like you can't.
Yeah. For how long? Yeah, that would be like 2.
then you look at
I've done way too much math. That's one of the last week. Everything is merging into one.
I don't call you Missy because I'm not sure how far they will fit. But it'd be like Missy.
Who you said like,
I got it.
So much for I gotta be called this now. Ain't on your name. Okay, so it's you. Okay. So, but then because that's attached to that, so that'll be multiplication. Oh, wait, hey, that, okay. 3 minus 1 is 2. Are you supposed to plug in 2 for some? Yeah, it doesn't make sense. I'll get back to it. I'm just gonna leave it.
all right, let's do A, B, and C. Who graphed it? Or knew how to graph it? Huh? Graphing it? Who was able to graph it? We're going to graph it.
Because shouldn't you just say that the coefficient on A is positive? Oh, wait, no, it's right there. I was like, yeah.
If a function's in standard form, how did we graph it? If a function is in standard form, we find the vertex, and then we find our intercepts. So, how did you find the vertex?
Oh, that's what it is. Okay.
You plug that, and then that gives you the y, so that gives you the 4 number force. And then to get the x-intercepts, you make y equal 0. So with the x times t, you make that equal 0. For the y-intercept, you make all the t's equal 0. And then I just write it.
So, how do you find the vertex? What is it? Negative b over 2a is the x coordinate. What's our y coordinate? You plug negative b over 2a into our function. Right, and so in our case, our x coordinate of our vertex was negative 4, or I'm sorry, positive 4, and then we just plug that into our function. And then, all you do is vertex, and then intercepts. That's it. You have to get both x and y. Okay, so let's answer A, B, and C about this problem. So, how many seconds pass before the ganette entered the water? How do you get that?
Because the first x-intercept is 2.
Right, this first x-intercept is 2. Remember that this is, our x-axis is the water. So once it goes below the x-axis, the ganette is in the water. So it's so A is 2 seconds. What's B? B is how many seconds did the ganette come back out of the water? So it comes back out of the water when? At 6, right? It comes back out there.
So 4.
The question you could either say is 6 or 4. If you read part C, then you'll realize that B was actually asking for the time from the beginning. So if you look at C, it's how long was the ganette underwater. So it's 6 minus 2 is 4, right? This time is 4. So B is technically 6. Yeah. Everyone good with that? All right. Let's see if we can answer these. What was what was the deepest dive of the Gannett? How would I figure out deep? What's the deepest dive of the Gannett? So if I'm dealing with what's the deepest dive of the Gannett, is that X or Y's?
What?
Y's, right? So I want the deepest dive. So I want which Y value is the lowest, right? Vertex, right? If this it is the vertex, right? The lowest Y values are the vertex because my parabola is opening up, right? This you can also call this a minimum, right? So this vertex, right, is 4, -4.
Oh yeah, we actually can.
And so the deepest dive of the Gannett is 4 feet below the water, right? Or at positions -4 feet. After how many seconds was the Gannett at its deepest? Is seconds X or Y's? X, right? So after how many seconds was the Gannett at its deepest? If I'm thinking in terms of quadratics, what is that looking for?
The X.
Huh?
The X.
The X vertex?
Or the X point.
The X coordinate of our vertex, right? So I'm looking for how many seconds went by before the Gannett reached its lowest point, right? Which I know, since my parabola is opening up, my lowest point is at my vertex. So E is going to be 4 seconds. And so let's look at F. After 7 seconds, the Gannett burped and dropped its fish. At what height did this occur? How do I figure that out?
Distance between 12 and 2.
Say it again?
Your y-intercept is 12.
My y-intercept is at, yeah.
You started at 12, right?
Yeah.
When you dove into the water,
Right.
and then you came back out, right? Here's what everything will be going.
So this is parabolic, right? So after 7 seconds, the Gannett burped and dropped its fish. At what height did this occur?
I think I get what you're saying.
Is really this information, the Gannett burped and dropped its fish, is that relevant?
No.
No, right? So after 7 seconds, how high was the Gannett? Is essentially how you could simplify this question. Right. If it's asking after 7 seconds, what is the height of the Gannett? I know that this function that they give me, right, is the height relative to time, right? How high am I based on how much time has elapsed? So I know that my function is what? It's h of t squared. H of t equals t squared minus 8t plus 12. And after 7 seconds, the Gannett burped and dropped its fish. At what height did it occur? So I just plug in a 7. So h of 7, which equals whatever it equals. 49 minus 56. 5. Yeah. So this is one situation where a quadratic is appropriate, right? And there's plenty of other situations. If I was to take this expo marker, right? So this is a situation where a parabola came down and then back up, right? I'm sorry, our Gannett came down and back up, and so we had a parabola opening up, right? But if I took this expo marker and I just tossed it like that, that's also a situation where I could model with a parabola, right? My expo marker started down low and it traveled up, up, up. It hit a maximum and then it just came all the way back down. And in that case, that's a situation where I could model with a parabola like that, where I have a maximum up here. 4.2 is applications of quadratics. So you're using everything you learned Thursday for the real world problems. That's all it is. The rest of the time is yours. I think you got like 3 minutes before lunch.
What value is there? What fraction? Because it can't be zero.
I started reading and then I decided to I feel like we're going to the index.
So it can't be -3.
I like that.
You see, you're rubbing off when you go there. But the answer is C. You're right. Your birthday tomorrow?
Yeah.
So turn up.
You don't got it.
Okay, give me 1 second.
I have a song playing in my head. I'm just having the song stuck in my head. Yeah, I know my voice is. Oh, no. I just hate this annoying chord. It's just annoying but catchy. So it's impossible to get out.
That makes
Oh, okay.
This one I don't want to.
all right.
I guess we can close out.
I think I've seen this.
Somebody else does. Somebody else does. They weren't even asking me to do
What do you want?
They weren't asking me
Jason, what you eating? What you eating?
Cough drop.
Oh.
Really is just like,
That was about the funniest bag of it.
I wasn't even gonna beg. You should like. I know this is related to the ACT, but the ACT. I was wondering if you knew what the answer to this is. I mean, we have no idea how the answer would be. Let's go into the
so you have. So they want you to do.
Yeah, I can't tell you.
So.
But you can come sit with us. Are you sure? Well, then you don't.
Yeah.
And they have like that.